So, like I said, in today's chemistry lesson, we gonna look at electrolysis, and in a nutshell, when you hear the word lysis, lysis simply means to break down something. L-Y-L, you know, Lysis. It means break down. Then electro from electricity, from electricity. Okay. So that process that involves the use of electricity, okay, to break down chemical compounds. That is what we refer to as electrolysis. Okay, is that clear?
Yes, sir.
All right, sharp. So we have some terms used in describing electrolysis. But meanwhile, we'll first explain the meaning of electrolysis itself. So electrolysis is the decomposition, that is the breaking down of ionic compound by electricity, as simple as that. Okay, the breaking down of, ionic compounds that are ionic, those compounds we have in them, metals and non-metals, okay, by electricity. That is, electrolysis. Now, the ionic compound can be aqueous, meaning it can have water in it, and also be molten, that is melted, right? Now, examples of ionic compound include sodium chloride, aqueous or molten, potassium chloride, aqueous or molten, copper sulfate, aqueous or molten. Then you have the magnesium nitrate. Okay, so now these ionic compounds contain positive ion and negative ion. For instance, sodium chloride. Sodium chloride, when it's ionized, when you pass electricity into it, it's going to give us sodium ion. Okay, and chloride ion. And that is after electricity has been passed into a. Are you with me?
Yes, sir.
Good. Similarly, when we pass electricity into potassium chloride, it's going to split into potassium ion, which is an ion, a cation precisely, and chloride ion. Okay. Then also for copper sulfate will split to give you copper ion, which is copper 2 ion, and sulfate ion, right? SO4 2 minus. Similarly, magnesium nitrate, when you pass electricity into it, okay, it's gonna give magnesium ion and then also nitrate ion, NO3 minus. But meanwhile, you need to balance this one, okay, because of these two here. So you add 2 there. Okay, so this is what happened to them when they ionize. when they ionize, okay, when you pass electricity into them, electricity is going to break them down into their component ion. Is this clear? Hello?
Hello, sir.
Is this clear?
Yes, sir.
All right, good. Now, as solid, ionic compound will not be able to conduct electricity. Ionic compound don't conduct electricity if they are solid. Why? Because the ions will not be able to move about. So you can't use solid for electrolysis. The only ionic compound you can use are aqueous and molten. So when they are in solid states, they would not be able to conduct electricity. Now said, however, when they are melted, right, or dissolved in water, so what will happen then? The ions are free to move and conduct electricity. Okay, the ions are free to move and they will conduct electricity. So the liquid or solutions are called electrolytes. So all we have here are nothing but electrolyte. So in the real sense, or in a nutshell, what are electrolytes? So electrolytes are molten or aqueous solution, all right? They are molten or aqueous solution of ionic compounds that are decomposed during electrolysis, right? They are decomposed during electrolysis. So they gave us examples: sodium chloride, potassium chloride, copper sulfate, aluminum oxide. So when we split sodium chloride, we learn that it's going to give us sodium ion and chloride ion. Then for copper sulfate, it's going to give us copper ion and then the sulfate ion. Then can you tell me what will be formed when aluminum oxide decomposes, or sorry, when it ionizes? Can you tell me?
Al3 plus and O2 minus.
Al3 plus and then O2 minus. Is it balanced? Check it.
2 Al3 plus and 3 O2 minus.
So we add 2 to what? To the Al3 plus, right?
Yes, sir.
And 3 to that. Good. Good. So you can now, copy this in your notebook.
Can you spell answer? Can you spell answer? Desconfiança. Bonsa.
Good. Now, the next term we use in electrolysis is electrodes. Okay, those electrodes are like rods. They are like wires or plates, and through them, currents can enter or leave the electrolyte. Okay, now these two rods you see in these pictures are the electrodes. Okay, we call them electrodes. So they can be in the form of rod, and at the same time, they can be in the form of wire. And it is actually through them current would enter or leaves the electrolyte. Now the electrolytes are here. Okay, the electrolyte are in the beaker or that containing vessel. This rod will always be will also be connected to a DC source. Okay, so those are electrodes. So the electrodes are of two types. We have those ones that are anode, and we have the one that is cathode. So one of them is anode, one of them is cathode. So meaning there are two electrodes. We have the anode, and the anode is the positive electrode. Okay, the positive electrode, that is the anode, and the cathode is the negative electrode. So this negative electrode is the cathode, right? Now, these are terms we use in describing electrolysis. And another term is the electrolytic setup itself. Here is an electrolytic setup, okay? And it said is an assembly of two electrodes, right? Assembly of two electrodes. When we say assembly, it means arrangement of the two electrodes, the cathode and the anode, all right, in a given electrolyte, okay? This is electrolyte. The electrodes are inside the electrolyte, connected to the DC source. This is the DC source through the wires, right? This wire, the red lines there, they are wire. The wire connected to the electrodes and then connect them to DC. What is the meaning of DC? DC Do you know the meaning
That's
of
correct.
very good? Direct current. Good. So we have that. We have that. Now that this is an electrolytic sector, arrangement of two electrodes or assembly of two electrodes in a given electrolyte connected to a DC source. And when we say discharge is also another term we use in describing electrolysis. And when we say discharge, it means gain or loss of electrons. Okay, the gain or the loss of electron to become neutral. To become neutral. That is the meaning of, electrode. Now look at this chloride ion now. Is losing an electron, okay, to become chlorine. But because we need to balance this chlorine is a gas, we have to add two. So which means it's losing two electrons. Similarly, this sodium is gaining, should be one electron, it will be gaining. Or because we want to balance it with chlorine, that was why we put two. Okay, but one electron is okay to balance the sodium. But because we want to, if we write overall reaction, then we might need to add the two there. Okay, so that is discharge. And something you need to know that electrons are negatively charged. And in the electrolytic setup, you need to also know that in the electrolytic setup, current is carried by ions, okay, through the electrolyte. So the current is carried by ions. The ions, the sodium ion that we've been producing, the chloride ion we've been producing, they are being carried by current, but electrons flow through the wire. Okay, electron will flow through the wire, while the ions will flow through the electrolyte. Okay, so those are the terminologies we normally use in, electrolysis. Then before we move into the uh, mechanism of electrolysis itself. Now let me allow you to complete the terminologies now, so you can write further. You can write further. I hope the everything is clear there. All right.
Can you scroll down, sir? Can you scroll down, sir?
All right, kindly draw this diagram. Why I label its parts. This is the cathode. This is the negative electrode. Why this is the anode, which is the positive electrode. And then we have this to be the electrolyte. This is the wire, and this is the DC source. One is a beaker or containing value.
Done, sir. I'm done, sir.
All right. So now, to explain further, they gave us a code here to comprehend effectively the concept or the mechanism of electrolysis. Here we have that during electrolysis, cations, you know what cations are, right? They are the positively charged ion. So during electrolysis, the cations will migrate, okay, will move to the cathode. We move toward the cathode. That is the negative electrode. That is where they all move to. While anions, which are the negative ions, will move to the anode. That is it. So you have the cations moving to the cathode. We have C to C and then A to A. So which means that cations, which are the positively charged ion, they are the positively charged ion, they will move to where? To the cathode. While the anions that are the negatively charged ion will move to the anode. Cations are positively charged. They move to negative electrode. Negative electrodes, okay, attract the positive ions because unlike charges will attract. Unlike charges are those charges that tend to attract, while like charges will repel, right? So because these are unlike charges, that is why opposite charges are migrating to their poles, okay? That is why the opposite charges are migrating to their poles. So we have this summary box explaining that. Now in the summary box, we have electrodes, okay, which ions are attracted to the electrodes, right? For anode, negative ions, okay, will attract to it. For cathode, positive ion will attract to it, right? Then what happened at the electrodes? Okay, now ions are discharged as well at the electrode by losing electrons, meaning at the anode, oxidation will occur. At the cathode, reduction will occur. So ions, positive ions are discharged by gaining electrons. Now you need to know that in electrolysis, oxidation will always occur at the anode. And what is oxidation in terms of electron transfer? Oxidation is the loss of electron, okay? And the gain of electron is known as reduction. So reduction occur at the cathode, while oxidation occur at the anode. So we normally use this code as well to comprehend that, to understand that. That is cryo. Which means reduction occurs at the cathode, oxidation occurs at the anode. That is what that means, okay? So it said oxidation is the loss of an electron, reduction is the gain of an electron. Is this clear?
Yes, sir.
Good. So we're proceeding to electrolysis of ionic melting now. Watch what? Melting ionic compound, not just an ordinary ionic compound, not aqueous this time around, but rather molten. Okay. Now, binary ionic compound. When you say binary, what does it mean? Do you know the meaning of
Base 2.
binary? Sorry?
Base 2.
Good. True. True. Bi means two. So binary ionic compounds are made from one metal combined with one non-metal. That's it. For instance, this is lead bromide. Okay. It's formed from lead and bromine. Okay. This is sodium chloride. From sodium and chlorine. This is aluminum oxide. From aluminum and oxygen. We have iron chloride, iron and chlorine. Okay. So the electrolysis of this compound, when in molten state, produces a metal and a non-metal. That's the objective. So when they ask you, what would be the product of the electrolysis of lead bromide, for instance? They say lead and bromine. And let's look at examples. Okay. Let's look at this example. Sorry, a moment, please. Just a moment. So now, sorry, in the electrolysis of molten lead bromide, they want us to perform the electrolysis for molten lead bromide. So the electrolyte is the lead bromide. That's the electrolyte. Okay. The electrolyte is lead bromide. Then what is the cation? The cation is lead ion. What is the formula for lead ion? Can you tell me the formula for lead ion?
Pb2.
Positive. You forgot to put positive. Okay. Then what's the anion in lead bromide?
Br minus.
What's the name? What's the name of Br minus? Bromide ion. All right. So you write it as Br minus. Then discharge of ion is going to take place in two locations. The discharge of ion at the cathode and also the discharge of ion at the anode. Don't forget that reduction occurs at the cathode. Now, at the cathode, what's going to migrate to the cathode? That is the lead ion will migrate to the cathode, will go to the cathode, right? Then you now write an equation. So you write that the lead ion that is the Pb2 plus will move or migrate to the cathode. Okay. So when you move to the cathode, what's going to happen? We said reduction is defined as the gain of electron. So lead is going to, reduction will occur at the cathode. So lead ion will gain electron, okay? Because of the two charge here, so it's gaining two electrons. So on gaining 2 electrons, okay, we're going to have lead being deposited as the solid. Is this clear?
Yes, sir.
Good. Now, for the anode, as for the anode, what's going to migrate? You write up bromide ion will migrate to the anode. So when it migrates to the anode, what's going to happen at the anode? Oxidation. So it's going to lose electron. So on losing electron, we have to write the equation Br minus, okay, is losing electron. That's why the arrow is coming immediately. So to become Br. But this is not stable. You need to put it as is a liquid. So you have to put 2. So because of that 2, you need to balance this to put 2 here as well. That is why is losing 2 electrons. So this is losing 2 electrons, while this is gaining the 2 electrons. So the 2 electrons can cancel out. So in a situation where you are asked to write the overall reaction, you might be asked to write overall reaction. And in the overall reaction, the 2 electrons will cancel out. One is at the product side and the other one is at the reactant side. Okay, sorry, I want to include the overall reaction. And if I include the overall reaction, I will need to adjust the whole of this. Okay. So in case you were asked to write overall reaction, so in the overall reaction, you bring this, the lead ion, Pb2 plus, and that of the reactant side of this, that is plus 2Br minus to yield Pb solid. That is Pb solid plus Br2 liquid. Okay, this is the overall reaction. Is this clear?
Yes, sir.
Okay, good. So you can write this down now, and I will give you that to practice. I think you're writing from here, right? If I'm right.
Yes, sir.
Okay.
Can you scroll down, sir? 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 Can you scroll down, sir?
Can you complete this using the previous format? Can you try it?
Yes, sir. I sent it to you, sir. I sent it to you, sir.
All right, good. I'm going to check my mail for that. All right, so we're going to stop here for today by God's grace. Do you want to ask any question?
No, sir.
All right, in the absence of question, do have a lovely day ahead. Bye.
Bye.